Who does that? But this is a for real situation. You can look up news stories about it. This really happened. So there was a little kid who really likes giant African land snails, and he snuck 3 of them into the country. They traveled to Africa, and he brought home snails, as you do. It was the 60s, you know. They didn't pay attention. And his grandma got tired of caring for him and released him out into the garden. 7 years later, those 3 giant snails turned into 18,000 snails with no natural predators. So, this is a real thing. So, what we're going to do is we're going to use this real-life situation to do some mathing on it, and so we can figure out what's going on with these snails. So, we're going to assume that with that growth from 3 to 18,000, that is a form of exponential growth. So what we're going to do is we're going to figure out an equation for these snails. So, what do we notice? In the end, there's 18,000. So we know at some point we have a total of 18,000, right?
In 7 years.
In 7 years. So if we think about the equations we normally write, we usually do that as amount, principal, 1 plus or minus r to the t. All right, this is the equation we've been working with the past few days. This 18,000 is going to go where? Is it the P? It's our A. So we have 18,000 as our total.
Oh, and the 3s are starting.
The 3s are starting. We started with 3 snails. So the 3 is going in for what? P. Oop, I was about to write the letter P again. So it's going to go in for the P. 1. We know it's growing because it got way bigger, so I'm just going to switch it to a plus. What else do we know? Did it take 10 years to get to 18,000?
No, it took 10 years to completely eradicate.
It took 10 years for them to eradicate that. It took 7 years. Is the 10 involved in this process of snail growth? No, that is a separate sentence. That's a distractor sentence. So this 7 is the amount of years it took. Can we figure out this rate from here? Could we figure out how much they're growing by? Can we get R by itself? We're not going to distribute because it's got an exponential on it. What could I do instead of distributing it? Not substitute something. We're just, I'm going to change the view on us real quick. What if we what? What if we divide? I have this 3 times the thing. Let's get that 3 to go away so that we can deal with the exponential piece all by itself because holy cow is he gross. So if I divide both sides by 3, that's going to give us 18,000 divided by 3 is 6,000 equals this little basey piece. So we've got our 1 plus r to the 7th. I don't like where I put that, so I'm going to move this up a smidge. There we go. What can I do to get rid of an exponent like that? It's been ages since we thought about one. It's like a square root. But it's not a square because it's not a 2. So what can we do? was gonna say it's like a square root, but since it's not a 2, what kind of root's it gonna be? It's gonna be a 7th root, which is even grosser. This is not gonna be a thing we have to do frequently. And there's a button on the calculator that'll let us do it. So I'm gonna show you. Boop, I gotta let my calculator load though. It's gonna think for a second, so I'm putting this back up. So we wanna try and get this chunk by itself. So I have to unraise it to the exponent here. Again, not gonna be a super thing that we do all the time.
3.
So the way we do this is in our calculator, we're going to put in that number, the one we want to take the root of. It's called our index. Then we're going to hit that green button on the top left, and we hit our any exponent key. That gives us our any root. So we're going to do our 7th root of 6,000. And that tells us we have 3.465. I'll just take 3 decimal places. So 3.465 is this 1 plus r piece. So that's our base. This actually is, we talked about this the other day, this is our growth factor because this chunk is the factor. So for part A, the question is actually not asking us to find out the rate. It's just asking us to make an equation for t. So I don't need to have all the way down to the rate for part A. So all we're doing is we're looking for that base. So we can figure out the total number of snails by taking the 3 that we started with and using that growth factor of 3.465 to the power of t. They didn't ask us to find the rate. They asked us to write an equation for t. You can absolutely go all the way down to the rate, which we're gonna in the next question anyway, but you don't have to here because all we needed to do was to get everything else so that we could write an equation for t. So we needed our starting amount and our growth factor to write the equation. Those are the only pieces we need. So questions on A, because we kind of went at it a sideways way. Okay. So then we're going to look at part B. By what percent did it grow each year? So that's the equation that we worked on the last one. So we looked at, sorry, we have our, it's stuck following my brain here. Our equation that we just wrote was A equals 3 times our 3.465 to the t. And we figured that out by using our 7 years. So by what percent, meaning what is our rate that they grew each year? We found our growth factor. We want our rate now. Say it again.
Is it 246.5%?
It is. How'd you figure that out?
Because you do 1 minus that number in the parentheses.
Yes. I see where you're at. You then did it like a weird side thing. So what we did was we looking at 1 plus r equals the 3.465. Because if we think about our OG equation, principal times 1 plus or minus r to the t. So we're trying to take this chunk here and figure out r. This chunk is this chunk. So you said, the way you said it works, I'm just explaining it a little bit. Yes, dear. Oh, okay, cool. So to get to that r, to get r all by itself, we can subtract 1 from each side, right? That way r is, as a decimal, 2.465. So to get it as a percent, since they asked for percent, we scooch it twice, 246.5%, and this is why they don't let you bring snails home from vacation. Because they grow by 246.5% each year. So what I want you guys to do now, and I want you guys to try this, I want you to see if you can figure out by what percent it grows each month. We calculated this by the year. So see if we can figure out, and I would recommend like start over. See if we can figure out how much it grows by month. Figure out how many months we know, and do the same process to figure out what percent it grows each month. Okay? So that's part C. So use the information we have. Use this as a guide and see if we can figure out how much it grows per month. What's that?
What does the T represent?
T is time. So whatever unit of time we have. In this case, since we did everything based on the 7 years, this T means year. So if we want to make it be out of months, we might have to make some adjustments. So I want you guys to try. Take like 5-10 minutes and see if we can try to figure out how much it grows per month. I will put it on this page for now. This was all about years. So see if we can figure out what we would need to do to make it months. How we do that, I'm going to pretend forgetting to do that. I always get so excited by our things that forget to do it again. Sorry. Oh, put it back. Weird noise. There we go. The HLA kids dismissing. Yeah, very close. They are. It's a slug, but it's been kind of broken, and I haven't had a chance to print more. So right now it's kind of a disassembled slug. It's been dismembered. Yes, dear. Yes. So what kind of room do you want to take? So put that number in first. Put the green button. And then turn any that's the button. Right there. And make sure you're really small. And you're doing your roots. Excellent job. You're headed exactly the right direction.
I don't know what T means. I'm kind of stuck on that.
Alright, where are you stuck? Let me see.
With T. Well, like,
Which
I just
T?
want to know my T for this equation. Because if we're learning from grade, is T automatically year?
So they told us 7 years. So that's where you got the 7.
Yeah.
So if we want it in months, on those 7 years, how many months is that?
7 years.
Mm-hmm.
So 84. That's 17. Okay.
Yeah. Rounded. It'll be 2 to 3 decimal places. We will never need more specificity than that. That'll be easier to see. All right, I feel like you guys are doing awesome on this. The ones that I've seen, you guys are doing great. So I'm gonna start talking it through for part C. Sorry to have some people looking over a D. My goodness. So we started out the same way. We know that there were 18,000 snails, and they started with 3. We're trying to find that rate. The thing that's different here is if we're looking for months, I'm not going to use my 7 years. I need to use months. So I know that there's 18,000 after 84 months, which I got because I need the music to turn down, please, because it's really, really, really distracting to me. Whatever sound we're listening to over here, I need it to turn down because it's really distracting. I don't think he can either because it's really loud. Turn the music down. It's very loud. It's loud, your music. I don't know whose it is, but I'll come play Find the Headphones. It's over here and it's loud. That's better. Thank you. It's very distracting. All right. So we treat this the same way. We're going to divide by 3 on both sides. It's going to give us our 6,000. 1 plus r to the 84th. And then we're doing that root again. We're going to do that funky root. I'll do it again on the screen so we see it. Again, not going to be a thing we have to do super duper common, but it's one of those things that you never know when it shows up. So we're going to have our 84. We're going to take the root of that. So I'm going to hit the green button on the top left. And then I hit this any exponent. The little green letters above it say x and a square root symbol. That means we're taking the any root. So we're going to do our 84th root of 6,000. Gives us 1.109. I'm going to take 3 decimal places. I very rarely will need more from you on that. So we have 1.109 equals 1 plus r. So what is our growth rate? What is the rate? 0.109. So what is that as a percent?
11%.
Yeah, you round it 11% or 10.9%. Scooch it over twice. 10.9% each month. So these snails increase in population by 10.9%. Which seems like not too much, but then again, also a lot. Because it grows by like, what was it, 200% a year? So looking at part D, it says to use technology to make an estimate. When it says use technology, we are going to get our very bestest friend out. Meaning either we guess it and check it in the calculator, or we going to go on Desmos and graph it. I'm going to go on Desmos. We want to know when the population doubles. Not desktop. There we go. Desmos. Graphing calculator. So what I'm going to do is I'm going to type in our equation here. That was our 3 times the 1 plus 0.109 raised to the exponent of x. There we go. Steps on 1 and 1. There we go. I just want things labeled so we can see stuff. So, what are we looking for when the population doubles? What does it mean for the population to double? Multiply by 2. What was our population we started with?
18. Oh,
3. So what are we looking for our first population to double? 6. We want y equals 6 for the first doubling. So how long does it take for it to get to 6?
7 something.
7 somethings. Well, looking at this equation, what was our somethings?
Years.
Which equation was this one?
Oh,
This was the months one.
Oh.
So we get to 6. So it took almost 7 months for it to get to 6 snails. Oh, I'm gonna erase this line because I'm gonna change the view for a second. So for it to get to 6 snails, took almost 7 months. How long for it to double again? That took about, let's call it 6.5-ish months. How long to double again? What would the next doubling be? For a total of, yeah. So if it doubled again, it would go to 12. That is where I was trying to undo with the back button up here. So if we go from a total of 6 to a total of 12, how long did that take? Yeah, about 6.5, right? So it takes the same amount of time to double no matter how many it is. It's doubling. So it takes between 6 and 7 months for it to double each time. Doubling is an exponential growth. Okay? So we're going to see more equations like this later on. But this is where we're starting to play with these exponential things. So our D, we did, just so I can have it written down, on the Desmos. And it takes between 6 to 7 months to double. So this was the separate thought for question number D. Okay? So these kinds of situations do happen in real life. This is a for real invasive species. This is a real thing that exists. This is a really thing that happens. Real dude smuggled 3 snails into the country because he thought snails were cool, and then they started eating all of Florida's plants. That's why they now have like new invasive species, because the snails took over and they brought in food with the snails, and then it became this whole other thing. And that's where the kudzus came from. Like, it's a whole thing. So, the last sentence where they're talking about the USDA and the 10 years and 100 million, that's, if you really want to look at it, that's question E. So, that's looking at an exponential growth versus an exponential decay. It's really complicated, and it's not kind of the vibe we're going for right now. That would be more of a pre-cal question, honestly, the way that they worded it. Just saying. So I encourage you to look at E and think about it. It even says right there, optional for additional challenge. It's an extra hard problem. Assuming that the cost of eradicating them is proportional to population, how much more would it have cost them if they stopped for another year or if they started a year earlier? So we're looking at a ratio there. But that's not a super thing. We did the part that we really needed to do here. So this is not a new homework. This is the same one from yesterday, which I do believe makes it homework 2. It's the Ponzi schemes one. We talked about it. Again, Ponzi was a real dude. It's named after him because he was the first guy to go to jail for it. So it was homework 2 is the Ponzi schemes, and it was the 2 pages previously. So you guys have time to work on that. Please do the freaking homework. If you are unhappy with your grade or if you are unsatisfied with your grade, each of these homework assignments is about 1 percentage point. So if you would like your grade in this class to go up a letter, go do 10 homework assignments. It'll go up a letter. 10 homework assignments is 1 whole letter for the semester. Like, we only have 20 homework assignments in the semester, y'all. Do some. There's some of us that have done a whole goose eggs of homework. None homeworks. Which means you are just giving up on 2 whole letters in your grade. Whatever your grade is right now, if you have done none homework, add 2 letters, and that's what it could be. You can still do them all until May 17th. That is the cutoff date for all late homeworks. They will close and lock then, and that is not optional or flexible. That is the date, because I have to have time to grade them before finals. Not optional. That is the close and lock date. I'm very nice until then, but it is not optional. So you have a month. A month from tomorrow is when homework closes and locks. Again, each homework in this class is about 1%. So 10 homeworks is a letter. Please do your dang homework. I know senioritis is a thing. But still, I'm giving you time in class. So you don't have to do them at home. Do something.